Welcome back, math friends. This is part 2 in a series discussing the reasoning used in mathematical proofs. In the first video, we talked about inductive reasoning, which is conclusions drawn from a pattern of true examples. Today, we're going to talk about deductive reasoning, which is a conclusion drawn from a chain of true statements. And the thing that we're going to prove is that the measure of x plus the measure of y is 90 degrees, and given this as our givens, this diagram. Now, I like to warn students that you can't believe the diagram, and that if you are looking at a diagram and trying to determine measurements from the way it looks or the size, we can't trust that because sometimes diagrams aren't drawn to scale. But if we're told that these are our givens, that there's something special and specific about it, then we can believe that. We're told that angle Z is 90 degrees. That's indicated by the box in the corner. So we are going to believe that. We aren't going to necessarily believe that this is 30 and 60 degrees. It may look like that kind of a right triangle, but since that's not told to us, it's not part of our given, so we can't assume that. If it were 30 and 60 degrees, we would have this proven. But we're not. We're given no indication on the measure of x and y. So we're going to have to work deductively to draw a conclusion from our chain of true statements. So what do we know? Well, we've just discussed the measure of angle Z is 90 degrees, and that's a given. And the way I'm going to walk through this proof is as a 2-column proof. This is something that's commonly seen in high school geometry. So we know this. Something else that we probably know from high school geometry or even before that is that the sum of all the angles in the triangle are equal to 180 degrees. So we're going to assume that we have that, and we're not going to need to prove it to use it. So this is the triangle angle sum theorem. At some point, hopefully in high school geometry, you will have seen this proven. And so we're going to use this as a true statement that we're going to be able to use. Now, I'm going to plug this 90 degrees in for Z. So we know that it's given. We know this is true. This is a theorem. So we're just going to substitute it in here. So we're going to have x plus y plus 90 degrees equals 180 degrees, and we've just done that by substitution. All right, so now we want to know something about the sum of x and y, so let's move the thing that's not x and y from this side over to this side. So I'm going to subtract 90 from both sides, and that's through the property of subtraction. You could also look at this as adding a same value to both sides, which would be a geometric translation. So that could be the property that you use as well. So there, depending on what you want to call this, this could also be a translation. And that would be a much more geometrical idea, is to consider this a translation to shift from here to here. At this point, we have the statement that we were trying to prove. That's right here. So we have proven that x plus y in this triangle is equal to 90 degrees. So you can put your mark here, QED, or whatever it is that you use to end your proofs. This is quod erat demonstrandum. So this is our conclusion, that x plus y does indeed equal 90 degrees. And we've drawn that conclusion by looking at this chain of true statements. This was told to us to begin with. This is something that we've been given in the past. We know how to subtract. Or this could be the, we substituted. We know how to subtract, or it could be translation. And so this gives us, we're ending with the statement that we wanted to prove. So this is deductive. This is what most of this is the thing that you see most often in your high school geometry class. Hopefully this was helpful in disambiguating and helping you understand the difference between inductive reasoning and deductive reasoning, and helping you understand these proof techniques and what it is that we're doing to get from one place to another. Cheerful calculations.